Okay, so we're going to be doing XY tables. You may have heard them called T-tables to graph linear and nonlinear functions, both continuous, which a continuous graph is a graph that is unbroken. Still scrambling to check. I haven't come back yet.
Organized? The backpack is too organized.
So a continuous graph is a graph that is unbroken. Here's what I mean by you don't pick up your pencil. If you start down here and you start drawing some curve, you just always stay in contact with the paper, pencil to paper.
Doesn't mean don't pick up your pencil.
So, discrete graph, this is lesson 4 of chapter 4. So we are going to be graphing functions using XY tables.
Is it 4?
Yes.
Wait, I still never this was lesson from yesterday.
Well, here's the good news. We're going to be doing some of the same stuff. We're still graphing functions. Yes. The lesson from the other day, the tricky part, which I'm thinking you might not understand, is finding the equation to go with certain patterns. Yeah, that's
Just maybe.
my suggestion was you're going to have to memorize like the perfect squares, the perfect cubes, the ones that go up exponentially. What?
Yeah.
I made you one.
Where is it?
Oh, you're talking about a chart for memorizing your squares? No, I haven't.
Yeah. Yeah. No.
I haven't gotten it. I thought you were going to send it to me.
Something.
So a discrete graph looks like this. It's just a whole bunch of points that are not connected. And the solutions, or the set of all solutions of an equation, forms the equation's graph. So when we plot the points and draw a curve through them, you are drawing a picture of the solution set. So I'm going to ask you to be able to tell me, given a certain scenario, if it makes sense to connect the dots or not, whether it should be continuous or not continuous. So we'll see examples of that today. I'll point them out as we go through it.
I'm done.
Little graph. Unbroken.
No.
Of points. Not connected. All right. So the continuous one is the one where I just draw a curve that I never pick up my pencil.
Oh, okay.
Discrete, just a bunch of dots. So graphing a function rule. This you've probably done before, okay, with linear functions. So we're going to be making XY T-tables. After I do these ones in great detail, we'll just be doing T-tables like this. I will be asking you to pick out the values to plug in. Okay. If you don't know what to plug in, my suggestion would be what we're doing in the notes right here: -1, 0, 1, and 2. So go ahead and write those down in the first column: -1, 0, 1, and 2, and just maybe make a note to use those. If, when in doubt, use those 4 numbers. For certain nonlinear functions. For a linear function, that's plenty of values to plug in. Negative 1, 0, 1, and 2. So you write that down in the answer. But when it comes to nonlinear, that might not be enough. What's cool about this method is it will work. You can, if you plot enough points, you can get an idea of what the graph looks like. It's not the most efficient, okay, but it'll work. And so this is how we're going to handle at least certain nonlinear functions. I'm going to show you a shortcut for linear ones soon. So we kind of have a format here in this second column. I'll let you write this down. So go ahead and write this down. We've got y equals negative 2 anytime you plug in a number for a letter in algebra. It's a really good idea to put parentheses around it. Parentheses in algebra mean multiplication. And so it looks like this. I'm going to put negative 1 in here and evaluate it. I'm going to put 0 here, 1 here, and 2 here. So as you go through this, we won't be doing quite as much detail. You'll just write down the x values, do the calculations probably in your head or on your calculator, and write down the corresponding y values. What's the first y value here?
Probably 3.
3. Negative and a negative is positive 2, plus 1 is 3. So we would just write a 3 here. Okay, this is what you'll be doing in your homework tonight.
Oh!
What I haven't read here is what you'll draw an xy table, and then you'll have to draw the graph and plot the points. Yeah. I've told you just to use these 4, the same 4 as I'm using in notes. Okay. Unless they tell you otherwise, or you think it might be wise to use something else, I'll show you when it might be wise to use different numbers than the ones that I'm giving you. Yeah. I thought somebody might bring that up. No, you can't use that yet. You don't know it yet. We're going to learn that soon.
Wait, but that's exactly what. Yeah, you use exactly what that is, though. So.
Right, but did you catch why I told you we're doing the tables? I actually. Okay, that's true. That's true. We're it's like we're pretending.
More work, bro.
It is more work, but here's the deal, guys. You haven't learned enough algebra yet to graph nonlinear functions without using the table. So you need to use the table for the nonlinear ones as well as the linear today. Okay, once I show you slope-intercept form, then you can use the shortcut. So that's 3. This is 0 plus 1 is 1. You start to see, now that we know this is linear, we start to see a pattern here. Negative 2 plus 1 is negative 1. And then here, what's the next one in the pattern? That's 6. It's going down by 2 each time. Negative 3. So what you need to understand here is that XY tables produce coordinates. These are called coordinates. Yeah, I don't know if you've made the connection before, but those are coordinates that we graph. So please fill in the coordinates, please. Fill them in as coordinates. When you're doing your homework, you can go straight from the T table right here. This is the little T or XY table. T table, you see the T in there? XY table to graphing or plotting the points. You don't need to list them as coordinates. But we're trying to help you make connections here. It's like, here are the X's. Alonzo, how did I get these X's again? Doesn't matter.
Wait, what?
That's what I thought. How did we get these X values? Yes, good. Just like whatever your mom's telling you. You do what your math teacher tells you, just like you do what your mom tells you. So, how do I get these Y values? Yes, it's the answers when you plug it in. So that's how we get these coordinates, and then we're going to plot them. Negative 1, 3 is right here. Negative 1, 3 is up here. 0, 1 is right here. 1, negative 1 is here. And 2, negative 3 is here. And then it's fine to go ahead and connect the dots so you can see what the line or curve, when we get to curves, looks like. Okay? Unless it's a discrete graph and it doesn't make sense to connect the dots. So that's what we're doing. Now, the now you try I'm going to do with you. To finish graphing this. Not everybody has plotted these points yet. Please do this. Plot the points, please.
Oh, that's a
Basically, the
discrete.
slope is 2.
Is it discrete? Wait, how is that two?
Yeah, for those of you who have heard of slope, this one up here has a slope of -2, yes.
Wait, how do we know this is straight though?
How do I know it's straight? Because, you guys tell me. How do you know? Look at the y values here.
It's straight.
It's not constant. Basically, it would be like a real life situation. Yeah, that makes it.
So what your question was, how do you know it's a line, or how do you know we connect the dots?
Yeah.
You can connect the dots unless it's a real life situation in which it would not make sense to have values in between where the dots are.
If you're buying gasoline, you can have coolant. You can have cool down, but if you're buying cans, you cannot.
You like take turns the ends up.
No, but that's a little demented, so we'll leave it there.
You wanted to say about cat.
Keep your cats away from Finn. He's gonna.
Yeah, you're gonna call him up.
So check this out, Alonzo. We're gonna. Well, just because you asked this earlier, I'm just gonna pick on you on this. So. Yes. Why is this going up by 2? Why am I suggesting? Here's what I'm talking about. Being wise about the x values we choose to plug in. Why the 2's?
So,
Yeah. So when you take half of it, it gives you a whole number. Yeah, it's because of the half in there. So here's what it looks like. Here's the plugins. Go ahead and fill us out, and we're going to get away from doing all the details here
It is.
after this. Okay, when you get to your homework, I'm fine with you just doing an XY table. I'm assuming you can do this in your head. Half of -2, at least in most cases, or on your calculator. Half of -2 is -1. Minus 1 more, -2. Yes, then.
Why is it -2, 0, 2, 4? Wouldn't it be, what are we using -4?
I know. So we had a tag team here, Caitlin and Ian. Do you guys want to tell Finn what?
Wait, Caitlin's next to you. Caitlin's the blonde one over there.
Ian's right here. They both had input. So Finn, listen.
one in
Yeah, Caitlin had an idea on that. She picked up on it right away. Caitlin, why did we choose 2? Multiples of 2. See that half of the problem? What's half of 1?
Half.
But what's half of 2?
1.
Isn't that more convenient?
Wait, so you can just pick the side numbers?
Yes, you do.
Oh,
And in
okay.
your homework tonight, you're going to just pick them.
Do you have to pick -2, 0, 2, 4?
No?
68.
Oh, 68.
You could. That's going to be a pain when you go to graph it. But.
Every day.
All right. This is 0. Half of 0 is -1.
-1.
And then half of 2 is 1. 1 minus 1 is 0. And then half of 4, 2 minus 1 is 1. So there are the 4 coordinates. Got -2, -2. So plot -2, -2. 0, -1. 2, 0. And 4, 1. And it would be fine to connect these.
That's
I think it'd be easier to fill in the y values here. Just put the y values in. The -2, -1. Put -1 in.
society.
0, and 1. So what you're plotting is the point of -2, -2. -2, -2. I plotted that one. 0, -1 is right there. Plotted at 2, 0. Plot 2, 0. And then 4, 1. The reason they're doing this middle column here is just to show you how they're getting the y's. That's it. I'm assuming you're going to do that in your head right on your calculator. Right. So we get our line drawn. Yes.
Wait, so whenever it's 1/2, it's better to use -2, 0.
It's better to use multiples of 2. What if it were here? Okay, let's stretch this. What if this were a 1/3 out here? What would be good numbers to use? Yeah.
Oh, so whatever the denominator is, it's... Wait, so then why For the first one we did 1.
Because on the first one, I could use -1, 0, 1, and 2. It produces whole numbers here when I multiply it, so we don't worry about fractions.
Okay, so this one.
This one has a slope of 1/2. All right, here's a real-world function rule. It says the function w equals 146c plus 30,000 represents the total weight w in pounds of a concrete mixer truck that carries c cubic feet of concrete. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph of the function rule? So I just went through and keyed out your test just today during my prep period, and as I was doing the problems like this, I was just reminded that you are required to think about and scale your axes appropriately. Okay, these are called the axes. Okay, the x and the y axis. The plural is axes. So I'm trying to help you on this one, but the capacity is 200. I'd like to know what the weight of the truck is when there's nothing in it. I'd like to know what the weight of the truck is at capacity, and then maybe something halfway in between. So what 3 numbers do you think I'm going to pick to plug in for C?
-1, 0, and 1.
Okay, but this is talking about pounds of concrete. Can I have -1 pounds of concrete?
No.
What do you think? 0, 100, and 200 is kind of, yeah, that's right. She read my mind.
Can you do like 0, 1, and 2?
Okay, but if you did 0, 1, and 2, you're going to have like 3 points really close together on your line.
True.
So
What happens if the graph was bigger? Would it work?
if you change the scaling on it, yeah.
True, I can't do that.
But if I tell you the capacity is 200 feet, I think it's a really good idea to draw the graph between the lowest that it could be in the domain, we call this the domain, which we're going to learn about later, and then the highest value that makes sense for the problem. Okay. So it's 0, 100, and 200. And then what we're going to do is take this equation, W equals 146 times 0 plus 30,000.
It's 30,000.
Yep. I was going to do that one and let you guys do the next 2. Stole that one from me.
You're welcome.
That's one I could do after lunch. My brain goes to sleep after lunch sometimes. So. Oh no, who's going to do the calculations here then, boys? So now we're going to plug in 100. 146 times 100. I can.
44,600. Right?
Oh man, we'll just let you carry us here. 44,600. We're plugging in 100 for C in this equation up here. Can you see that? Why do we use these? Because it made. No, I said Alonzo. That's the default. Well, do you know what a default is?
Yeah, like a default is good. Like a Fortnite.
Okay, the default is the go-to when you don't know a better plan of what to plug in for X. We came up with a better plan. I'm not sure where you were. You were talking to your mom. But we had. We noticed on here, right here, Alonzo, 200 is our capacity that the truck can hold.
Oh.
The truck is empty at 0. We've got to have those endpoints in there, right? And then we thought, well, halfway in between would be the natural
100.
point to try. So that's why we chose those 3 values. Then we're going to plug in 200, and we go up to, what's the next one? So this will take us up to what?
59,200.
59,200. 59,200. So let's not worry about writing these as coordinates. We've got C is kind of like our X, and W is our Y. So maybe just make a note of that. This is your X, this is your Y. So we've got a point at 0, 30,000. Okay, now we're scratching our head going, okay, I've got this, I'm trying to create a graph. Maybe on the computer, maybe you're the one creating the graph, right? You're going to present something here. What would you do as you create this graph and say, Excel or something like that, or Google Sheets or something? Go ahead. Okay, so along the X, you have the C's. So how would we scale this along here to make, what would you suggest?
0, 100, 200, or
You could, except that it's going to end right here. Right? You could. but-
25s, maybe 25s.
Why 25s? Or is that what you're going to say? Okay. Why 25s? I like that thinking. What'd you do?
Means you can get a more accurate graph.
You could. It'd be a little more spread out, a little easier to read.
Yeah.
If you're going to present this to somebody, you might want to choose a good axis. I mean, so believe it or not, I mean, even in my job, if I'm going to do a presentation and I'm drawing a graph on the computer, of course, I've got to pick the axis. I got to pick the scale. So
Ow.
25 is a really good idea. How'd you get the 25? 200 and if you divide it by 8, maybe?
No, we just stuck a random.
Is it really? There's 1, 2, 3, 4, 5, 6, 7, 8 on here in terms of what I have, so it makes sense to me to go by 25s. I thought that was a good idea. And then this is, of course, in cubic feet down here. And then over here we have weight in pounds. So this is weight in pounds, LBS. What's a good scale on this? Now this we might want to kind of have a break and then go up. But we go from 30,000 up to almost 60,000.
Oh, wait, 10,000.
We could go by 10,000s. We're going to get there really fast if we start at 30,000 here. Well, I guess we could go 10, 20, 30, 40, 50, 60. That works pretty good, yeah. Then we don't have to put a break in it. See, I'm spending the time on this because when you come to me as a senior in advanced pre-calculus, we learn to use the graphing calculator. The graphing calculator has a default window, right? Has a default window, and when you do real-life problems, you want the calculator to graph the line or curve for you, guys. You have to change the window up. So you need to understand this type of stuff as we move forward in math. You really do. You understand? You got to think through this stuff. It shows up on the Common Core exam too. Just being able to choose a correct scale, choose values to plug in, to figure out what the graph looks like, that type of thing. So I agree. We could say this could be in thousands. Okay, in thousands, and so we go 10,000, 20, 30, 40, 50, 60. So those numbers are in thousands of pounds. So the first one would be 0, 30,000. Okay, guys. Okay, the second one is 100, 44,600, which is right about here. And the last one is 200, almost 60,000. So it's just under 60,000. Does it make sense to leave this discrete or to make it continuous? Could you have 50 pound or 50 cubic feet? Could you have anything, I guess, could you have any weight along here? Could you have any Y value in pounds? Yeah, you could. You could. Well, at least to the nearest pound. You actually could go even more. You could. It makes sense to make this a continuous graph. Oh, I don't need to put an arrow on it though, because what did it say the capacity was? Stops there, yeah. Okay, so that's the type of thing we're asking you to do, is think about, what kind of graph this would be and
Wait,
draw
so
it.
you get 59,200.
I took 146 times 200. You could do it on your calculator if you want.
That makes sense.
And then added 30,000. You may have looked at the pattern. Did you look at the pattern to get it? Did you add another 14,600 to this one to get it? Or did you actually did the calculation? Okay. So either way, you could also add another 14,600 because it goes up incrementally.
Well, you can clearly tell it goes up if it's later by the 40,000.
Yeah, as long as the values over here in the first column are going up in the same increment, yes. Okay? Otherwise you have to fill in the in-between stuff. All right. I know this is a now you try. We're going to do it together. Do you think you could guess on what I'm gonna have up there in those three?
Ooh,
Oh,
You think you could guess?
yeah.
What do you think?
0, 125, 250.
Okay, let's see if he's right.
What? 100?
Oh, it's 100. Okay. 125 is a good guess. I may have chosen that if I were doing it. I actually didn't write these notes, but
I split it.
0, 100, 250. I probably would have split it. But there's one possibility. They're choosing a different one. So if we fill this in, we have 0, 100, 250. If you used 125, I wouldn't argue with you. I think that's what I actually used when I did it.
Oh, really?
Yeah.
Oh, okay.
This is 700. This is 1500. And 250, 16, 2000, 2700.
My
And
middle one, oh, yeah.
Your middle one will be different if you chose
It was
125.
1700.
Yeah, and that's actually, I remember that number. That's what I chose. Great minds think alike. And sit in the front row.
Yeah, thank you.
Even if we don't think alike. So 0, 700. So we've got to think about a scale down here. So what do you want for the scale here for the gallons down here? Any ideas on the scale for gallons?
I would say hundreds, but it can't fit.
Hundreds we're gonna already be at 300 right here.
Okay.
Any ideas on the scale on the bottom? We need ideas. Yeah.
Wait,
Did you pick one already? Oh, the y-axis? Okay. What do you want for the y-axis? 450s? Okay. So 900, so it'd be 1800. Okay. Okay, you good. How'd you get the 450? Okay.
wait, but this isn't linear.
It is linear. Look at the equation up here.
Oh.
Is it g to the first power? Well, it is.
Oh, yeah.
We haven't talked about it yet. If there's no power written on it, it's assumed to be g to the first power.
Okay,
It
yeah.
means it's linear. Okay, it's of the form of mx plus b.
Wait, but it doesn't go up to...
That's because of the value we chose here. That's
Yeah.
because of the with your 125 it does. So if these don't go up in the same increment as these, then we don't expect it to go up the same. But it would go up the same if I were to choose a 125 here in the middle. Yours went up 1,000 each time, right?
Yeah.
So it is linear. We could go up by 450s. I didn't think of that, but I agree that will work.
How do you divide by 6?
Because if you count these guys going up, there's 1, 2, 3, 4, 5, 6 of them.
Oh, that's smart.
Yes, I thought it was, and I didn't think that up. That was Sarah back there. So
Who's Sarah? Who's Sarah?
Sarah's in the back there. She's just quietly putting out
Being smart.
really wise
Sarah,
ways
that's her
to
plate.
scale our graph. So what would you guys learn from what Sarah did? What would you do with this 250 then? Divide it by what?
Divided by how many squares there is.
Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh. That equals 25. So we're going by 25s maybe again. Okay, this is just a suggestion. Would it be correct to choose a different one?
No.
For you, no. It actually would be. There are other options here.
So next thing.
But do you see how this makes sense?
Yeah.
So we have 0, 700. So 700 would be about right here. The next one is 100, 1500. So 100, 1500. We're estimating as best we can. You see my scale? So that's why I'm saying it doesn't matter what scale you choose. You'll have a linear function. You're going to end up estimating where the points are anyways because it's such a broad gap in between each one of the grid lines here. So 250 and then where are we? 2700. So there it is. Does it make sense to connect the dots on this one? Yes.
Yeah.
Oh, that's how it goes? Wait, what? Oh, yeah.
I think it does. 10 years graph. So, yeah, a lot of students don't like these because they're a lot of work. It can be
A little bit.
a bit of work.
I hate it.
It's not getting older.
It's just kind of like, it's just kind of, it's like looking at a photo. It's kind of like things a lot.
I mean, using the slope intersect way, that's way quicker. But
It is. You'll appreciate it when we get to that, when I let you use that. The problem is that's not going to work on something like,
that.
well, no, the next one. It's next one. It would work here, but it's the next one after this. I was hoping it was the nonlinear next, but kind of ruined my segue. Oh well. Local cheesemakers making cheddar cheese to sell at the farmer's market. So we're going to make an XY table. Here's how it works. 1 gallon of milk makes 16 ounces of cheese. So 1 gallon of milk is 16 ounces of cheese. 2 gallons is 32. 3 gallons is 48. Now, could you figure out a number of gallons of milk to create something in between 16 and 32?
Yeah.
Yeah.
So it's sounding continuous, right?
Yeah.
Yeah.
4 would be, add another 16 to this, 64. 5 would be 80. We're not going to go any farther than that. So this is a continuous function.
I'm gonna do that 6 just because.
Whereas, okay, when I go to market to sell these wheels of cheese, they call it. Okay, these are wheels of cheese.
Have you seen that spoilers cheese rolling?
No.
They all run right out of the hill after it.
And they do that in Wisconsin?
I don't know.
That's in,
In Australia?
No, I think it's like,
it's in Russia.
yeah, I think it's in Russia.
Okay.
Wait, no, I mean
No, I
Australia.
Australia.
Okay, so one packaged wheel of cheese would be $9. 2 of them would be 18. Now here's the deal.
27.
You cannot cut the package in half or in thirds or anything like that. So this is, you could, but they're not going to sell it that way. It would dry out.
Oh,
Wouldn't be good. So 5 would be
45.
I don't like cheese.
How can we do 6
No, like 64.
Yeah.
It's uneven.
54. So this one is discrete.
Like, yeah, cheese, but it's like,
This one I didn't go down any further because I can't graph above
Wait,
80.
why is this weird?
Because you can only sell whole wheels of cheese.
I don't know what we were doing.
So wait, if you cut it, then does that mean you have to eat the whole wheel? Right?
Wait, isn't that whole wheels?
You might, yeah.
Isn't that whole wheels? 9, 18, 27, 26.
Okay, so let's graph this one. 116,
you know what?
232, 348, 464. I don't know if I've ever had so many comments on this particular lesson.
Wait, what? Oh,
It's just a lot of cheese.
it's because you have a lot of questioning kids about cheese.
I know, you guys are very curious. You're really
Like cheese. Yeah.
into these scenarios here. So
Bruh.
1, 9. These ones are going to be discrete. 2, 18.
So why are they discrete though?
Okay, because you can only sell whole wheels of cheese. You're not allowed to cut it in half and sell it in half.
I thought that was a whole wheel.
Oh my god, Finley.
Right. So
I'm not trying to be
okay, so no. Right. So here's why it's not continuous. Okay, guys. Here's why it's not continuous. It doesn't make sense to calculate the cost for 1.5 wheels of cheese because you cannot sell it that way. That's what I'm telling you. You cannot sell it that way.
How much is 16
Oh,
ounces?
okay, I understand now.
No, you don't.
What do I do?
16
I didn't
ounces?
see the word probably first.
I don't know. I don't know how much is in a wheel. It doesn't say. It actually doesn't say, but this just says how much cheese it produces. I don't know how much is in the wheel. So 436, 545, and then 654. So linear pattern. Definitely a linear pattern.
Would we need like graphic for this? Since we need like exact.
I didn't know because it's not exact. I mean, it's really we're estimating. Even when I have the graphing grid here with the XY axes labeled for you, I'm still estimating, right? When I did the homework, I didn't. I just
You just
drew them just like that. I did.
Okay, but like, let's say your homework gets a little bit like you're like on the last minute right before class, and like you just draw random graphs. Is that okay?
No.
No, you actually have to.
How are you
like,
gonna learn
They
it?
make sense.
They need to make sense. Right.
Doesn't have to make sense. If it makes sense to you, it makes sense to everybody else.
All right, we are gonna skip the now you try for this one.
Thank you.
Yeah,
Thank you so much. I love.
Well,
Why you're my favorite teacher. You're my favorite math teacher.
sure.
We had one teacher.
Thanks, guys.
Yeah, you're our favorite teacher.
We did have a CX period. Oh my god. CX.
That's right. I do that with my kids. I say, "You're my favorite oldest daughter." You're my favorite sixth period class too. For 2010. All right, guys. What you can do is, I need quiet here so we all hear this. This is to answer the question, why aren't you just showing us the shortcut for graphing lines? Well, because not all functions are lines. There's a lot of nonlinear functions out there. When you're introduced to them in your classes that come, Algebra 2, Pre-Calculus, or even Calculus, you're introduced to some new function, the way you investigate it is by, well, you might be allowed to use a graphic calculator, but you're going to make an XY table, which is what the graphic calculator does, and it plots it for you. So these are nonlinear. Now, with the nonlinear ones, the default could be -1, 0, 1, 2. You could start with that, but that may not be enough points to get a good picture of what it looks like. In this case, I'm going through -2, -1, 0, 1, and 2 on this problem. I think will be enough. Now, what you may have to do is add more points in. Like the first time, it gets annoying.
It was being difficult.
So, right here, when we plug in, do you know what this symbol means? No? Good guess.
Absolute value.
Absolute value. So, here's what we're doing. Here's what we're doing. We're taking the absolute value of -2, which is
2.
2. -4 is -2. To get the coordinate, -2, 2. So you've got to evaluate it at each of these x values.
Wait, -2, -2.
Next one. Absolute value of -1 is 1. 1 minus 4 is -3.
Oh, so just it's going up by 1, but in negatives.
Question of you.
Yeah, it's going up in 1s by negatives.
There we go.
So it'd be 0, -4. Correct?
So,
Yeah.
Did you say nut?
all right, so y equals. No, that's not a good tutor. That doesn't help you to learn.
Aw. Wait, then that one's gonna be negative.
Okay, so we have absolute value of 0 is
Change that to a positive.
0. Well, positive 0 is still.
No, 0.
This changes to a positive, but then what's 1 minus 4 equal? -3. 0 minus 4 is -4. I think you should notice a pattern here. What do you think the next number is going to be? Oh, I just showed it. -3.
Oh, and then that one's gonna be -2.
It will be.
Hey, I found out the pattern. I'm a cool kid, not really.
Yes.
you're cool, my guess. Oof.
So those are your x coordinates and your y's. If you just wrote down just the x's and the y's, that would be fine. That's all you're going to do in the homework. You'll have an xy table. These will be your x's. These will be your y's. I'm hoping you can do this in your head, and it's not so much work. I mean, you're not. I have to show you where these numbers are coming from.
Yeah.
But if you understand kind of how to evaluate using absolute value, you're good to go. Here's what it looks like on the graph. -2, -2. It's kind of like the flock of geese function. You'll see why in just a minute. -1, -3, flock of geese. 0, -4, 1,
This
negative
one's-
3,
Oh, and it's gonna be like a
Is this
V.
discrete or no?
2, negative 2. No, we can connect the dots because it can be anything in between. You can plug in decimals.
Do we have to do the other one?
Yes, slugger.
Yes, we're going to do the other one. We get to do the other one.
I can't see the equation for that one though.
Here, I'll tell you what it is. I'll rewrite it.
Oh, it's right there. I'm done.
So,
A little bit.
every time, okay, here's the cool thing, guys. Every time you have an absolute value involved in your function, it will look sort of like this. It will be what we call a V shape.
What is that?
So at least you know what to expect. Okay, you guys, you need to memorize this and understand it. Is every time you see an absolute value, it will take this sort of shape. So what if you start to graph it and all you see here,
It's a line that you know you're doing it wrong.
well, no, not necessarily. If you only see this, so maybe, let me just erase these points. Maybe you only have that far. It's looking like a line so far. But I see an absolute value in here. What do you need to do? Maybe you stopped at 0. Add more points, right? Try more points because we know that it's eventually going to bottom out and then come back up again because we know what this generally looks like. So this could happen as you're going through and doing your homework or quizzes or a test.
Wait, X.
Absolute value always looks like this. It will be a V. It could be anywhere on the graph, but it's always a V-shaped graph. Whereas x squared, an x squared graph has a different general shape. It's called a parabola. It will have a shape that looks like this as opposed to our V up here. So let's go ahead and plug in these values here. If I plug in negative 2 and square it, what do I get?
5.
This becomes 5. Yeah, negative 2 squared is positive 4 plus 1 is 5. Then we plug in negative 1. 1 plus 1 is 2. Then we plug in 0. So 0 squared is 0 plus 1 is 1. Then we're going to plug in 1 and then 2. What's interesting about this is you should see a pattern.
It goes into like a thingamabobber.
That's right. It's slowly not.
It is a thingamabobber.
That's what I was thinking too.
Yeah.
Thingamabobber?
Yeah.
So it goes 5, 2, 1, and then back up again. 1, 2, 5. So looks like this. We have a point at negative 2, 5.
Do we have to make
A negative 1, 2.
Do we have to make the thingamabobber?
Yeah, that's what I was wondering.
0, 1. Yes, we're graphing the thingamabobber. 1, 2. 2, 5. And as I connect these dots, I'm keeping in mind that it makes a
Parabola.
parabola or a U shape.
Mr. Round, do we have to do the graph thingy for the number 1 on classwork? That's the table thingy.
Yes.
We do it on our head? Yeah.
No, you can do the arithmetic in your head. You still need to show the table value.
Okay, so
I won't know what
the
your
table.
I won't be able to help you if you're not doing it correctly if you don't show me what your table values are. All right, so I want you to do the classwork here.